Hello friends, we have started with the fourth unit, that is electronic instrumentation. You have studied up till now the DMM, digital multimeter, and function generator. The next instrument is digital storage oscilloscope. Before this you have studied different types of oscilloscope, that is CRO, that is cathode ray oscilloscopes. You have already used it in many of the practicals. The second type of oscilloscope present is the digital storage oscilloscope, and third one is a power scope. So in this lecture we are going to discuss about the details of digital storage oscilloscope. Digital storage oscilloscope is same as that of the CRO, only it is doing the additional function of storing the waveform in the digital form. There are two types of DSOs present, that is processing type and a non-processing type. The difference between these two is the processing type of DSO has the ability to process the input waveform, whereas the non-processing type of DSO can only store the waveform. Okay, so these both types of DSOs has the ability to store the waveform, but these oscilloscopes are storing the waveform in a digital form. Means first of all they have to convert the waveform in a digital mode. Okay, so we'll discuss the block diagram of this. Okay, so this is the block diagram of a DSO. Here you can observe the blocks. First one is the amplifier, then digitizer, digital memory, analyzer, waveform reconstructor. On the lower side you are having the time based generator, which is connected to the trigger and clock circuit. The output of the time based generator is given to the horizontal amplifier, and the output from horizontal amplifier and waveform reconstructor are given to the horizontal and vertical plates of the CRT. Okay, so we'll go one by one. So all of you are familiar with the CRT. What is CRT? CRT is cathode ray tube. Okay, you might have seen or learned this in the physics, okay, in the previous years. So first of all, our very first block is the amplifier. Before going into detail of each and every block, first of all we'll see broadly what is the basic function of this DSO. So first of all, whichever will be the input waveform or input signal, first of all this DSO will convert it into the digitized form. The digital memory will store that waveform, and the waveform whenever required will be displayed by reconstructing it. Okay, so these are some of the functions of DSO. Now we will see the working of each and every block in detail. The first block is amplifier block. The input signal is given to the amplifier block. Amplifier does the function of amplification as well as attenuation. That means whatever will be the input signal, that will be strengthened, or we can say amplified at this stage. The amplified input will be given to the second block called as a digitizer. Digitizer is the block which is consist of the two steps, that is sampler and A to D converter, or simply called as a analog to digital converter. Okay, so first of all the process of sampling is done. You might be familiar with the sampling process. Sampling is nothing but switching of a signal, or we can say a cutting of a signal, or taking the value of signal at definite time intervals, right? All of you are familiar with which type of signals we are analyzing on the oscilloscope, that is CRO. We always used to analyze the analog signals or AC signals, right? So here also input will be the analog signal. So first of all this will be converted into digital one by this block called as a digitizer. So very first process in the digitization is a sampling. So whatever will be your input signal, that is the we can say, suppose you are having the input signal which is an analog one. So first of all, this analog signal is converted into discrete signal by the sampler block. Okay, so sampler will convert this analog signal into discrete signal. Then the discrete signal will be given to the analog to digital converter, where again a quantizer block is present. That quantizer will allocate a definite digital word, or we can say a digital code, to each and every sample, and that will be further given to the digital memory. So each and every sample value will be stored in the digital memory as a definite digital word. Okay, in this way the input signal will be digitized and stored in the digital memory. Digital memory is nothing but a semiconductor memory. Okay, after this we are having the block called as an analyzer. In the analyzer block, the waveform will be further analyzed. Okay, and it will process the input signal for further information. Now whenever you will have a look at DSO, the front panel of DSO will just look like, we can say, it will be look like somewhat CRO with more and more number of functions. So digital CRO you have seen in the laboratory, so that type of DSO we can observe. And in the front panel of DSO you will be having number of function keys on the keypad, and on the other side you will be having the screen. So here by the analyzer block, the signal or input signal will be completely analyzed to regenerate or to produce the different information or variety of information about that signal. That is, what is the time period of a signal, what is the frequency of a signal, okay, what is the duty cycle of the signal. So such type of different information can be given by the analyzer block. After this we are having the waveform reconstructor block. The function of waveform reconstructor is same as its name indicates, that it will reconstruct the waveform. Now we know that whenever we have to display the signal, okay, that must be again in the analog form, right? Because we are providing the signal as a the input signal as the analog one, right? While storing, the digital storage oscilloscope converts that signal into digital form, but whenever it needs to display again that stored signal, it must be first converted into the analog one. So for that purpose the waveform reconstruct block will work, and it will again convert the digital stored digital signal into the analog signal, and it will be provided to the vertical deflection plates of the CRT, that is cathode ray tube. On the lower side you are having the number of blocks such as time based circuit. So here the function of this time based circuit, again this time based circuit is connected to the trigger and clock circuit. Okay, so clock and trigger will use to generate the pulses at the time based circuit whenever it will be required. So the time based circuit will generate the sawtooth waveform that will be again amplified by the horizontal amplifier. You might have seen the block diagram of a CRO before. Again there is a similarity, that signal is given to the horizontal deflection plate and the vertical deflection plate. So there will be the block called as a horizontal amplifier as well as a vertical amplifier. So same block called as a horizontal amplifier is present here, which will amplifies the output of a time based circuit, and that will be given to the horizontal deflection plates of the CRT for further display. So in this way the complete signal will be again stored, digital waveform will be again displayed on the screen of a DSO. Okay, so this is all about the working of a DSO. After this we are having the advantages of DSO. So we'll see what are basically the advantages of DSO, that is digital storage oscilloscope. First one is digitized signal can be stored for a very long time. Now the very first advantage we can see, or we can say that it stored the waveform in the digital form. Okay, so whenever a waveform is stored or a signal is stored in the digital form, first of all it will need a less memory as compared to the analog signal. It is very difficult to store the analog signal because it is having infinite number of values at each and every interval of time, whereas if we compare it with the digital signal is nothing but a discrete signal, and it is very easy to store the digital signal for a very long time. Second one, signal processing is possible. If we see that the processing type of a DSO is having the power to process the signal further. Okay. Third one is cursor measurement is possible. Now whenever you are going to operate this DSO, here you are having X and Y cursors. So whenever you can adjust the knobs of these X and Y cursors, suppose you have to measure the time period of a particular cycle, so you can adjust the cursors X and Y cursors, so that for particular portion of the waveform, the time period or frequency, whatever parameter you have to want to measure, that will be measured by using the cursor measurements. Okay, the next one is it is capable of displaying XY plot, PV plots and BH curves. Okay, so next one is applications of digital storage oscilloscopes. Now depending upon the applicability of this DSO, it is having very large number of applications. The first application is for measurement of AC voltage as well as AC currents. So again, same as that of the CRO, for analysis of AC signals such as AC voltages and AC currents, we can use the DSO. Second one, measurement of frequency, time period, inductance and capacitance. These parameters also we can measure by using DSO. It is mostly used in the radar systems. Again, in medical applications for plotting the cardiograms which is related to cardiac disease, it is used. Next one is to analyze the TV waveforms. Okay, whatever will be the sound signal, or we can say audio signals, video signals, these can be analyzed by DSO, that is digital storage oscilloscope. Again, it used to observe the radiation patterns generated by transmitting antennas. So it is having a wide application in the communication also. So that's all about the DSO. Thank you.